In this video, we are going to examine the different classifications of matter. So first of all, what is matter? Well, we can define matter loosely as the material that makes up all things. It's anything that has mass and occupies space. And matter is composed of tiny pieces that we call atoms. The properties of a substance is determined by the kinds of atoms, the number of atoms, and the relationship of atoms that come together. For example, let me give you an example. Carbon dioxide, we're all familiar with carbon dioxide. If you have one carbon atom that chemically bonds to two oxygen atoms, then you form carbon dioxide. Water is composed of different atoms. If you have one oxygen atom that combines with two hydrogen atoms, then you form a water molecule. And of course, carbon dioxide and water have very different properties. Carbon dioxide tends to be a gas at room temperature. Water tends to be a liquid. And so the kind and number of atoms that come together or bond together give a substance its unique properties. So when we classify matter, there are two general categories that we can start with. There are what we call pure substances and then what we call mixtures. Let's start with pure substances. A pure substance is classified as it's a type of matter with a fixed or definite composition. So let's explore that a little more. Pure substances can be further broken down into what we call elemental substances or elements and compounds. So let's talk about elements. An element is a substance that is composed of only one type of atom. We represent an element by what we call an elemental symbol in chemistry. All of the elements are displayed on our periodic table. So for example, if you have a block of iron, all of the atoms are iron, and so that would be an elemental substance. And we can give iron its elemental symbol of Fe, and we can see that on our periodic table. If you had a block of gold, again, if this is pure gold, then all of the atoms, all of the trillions and trillions of atoms that make up that block of gold are all the same type. They're all gold atoms. And so this would be considered an elemental substance. And if it's an elemental substance or an element, we give it a chemical symbol. And the chemical symbol for gold is AU. You can see aluminum, carbon, sulfur, all of these are elemental substances. So for example, if you had a diamond is an elemental substance. It's composed of all, if it's a pure diamond, it's composed of all carbon atoms. And carbon has an elemental symbol of C. Now, compounds, on the other hand, they're defined as two or more elements that are chemically bonded in the same proportion. So in a compound, you have two or more different types of atoms, different types of elements that come together and combine or chemically bond together to form a new substance. We represent a compound by what is called a chemical formula. So let's look at a couple of these. H2O, we're probably familiar with that. H2O is the chemical formula for water. And this chemical formula here tells us the composition of water. Water is composed of two hydrogen atoms, the H2, that are chemically bonded to one oxygen atom. So H is the chemical symbol for hydrogen, and we have two of those. O is the elemental symbol for oxygen, and we have one of those. So this tells us that this is a compound, which is a pure substance, and the chemical formula tells us its composition of atoms or elements that are chemically bonded together. Let's look at one other example. Fe2O3. Iron oxide is the name of this compound, and this is what we would consider rust. Rust, or iron oxide, is composed of two iron atoms. Fe is the elemental symbol for iron. And we have two of those that are chemically bonded to three oxygen atoms. And so iron oxide is what we call a compound. It has very different chemical properties and physical properties than either iron or oxygen by itself. So take a second and see if you can classify each of these substances as either an element or a compound. Pause the video and take a minute to do that. Okay, so here, the first one we have O2 is oxygen, and that's going to be an element because it's composed of all the same type of atoms. NaCl, sodium chloride, is a compound. We have two different types of elements bonded together. Pb, that's the elemental symbol for lead, and so since we only have one type of atom, it's an element. S8, that's the a form of sulfur that is most common, where you have 8 sulfur atoms bonded together, but since they're all the same type of atom, it would be considered an element. C2H4, that's a compound. C6H12O6, that's the chemical formula for glucose. And we have 6 carbons, 12 hydrogens, and 6 oxygens all bonded together to form a compound. So all of these are pure substances, but some are elements and some are compounds. So let's look at our second classification of matter, which is called a mixture. A mixture is a type of matter that consists of 2 or more substances that are physically mixed, but they're not chemically combined, and that is a very important thing to appreciate. So you can mix like salt and pepper together, but the salt and pepper do not chemically bond together to form a new substance, so you just have a mixture. You could also define it as 2 or more substances in different proportions, or substances that can be separated by physical methods. So like the example I gave, if you mix salt and pepper, you could separate the salt and pepper from each other by physical methods. If you mix salt and water, you can separate those. You can evaporate off the water. You can filter things, and those are physical methods of separating a mixture. Mixture can be subdivided into homogeneous mixture and a heterogeneous mixture. Let's look at a homogeneous mixture first. A homogeneous mixture is also called a solution. So we typically call that a solution. And it's when you have 2 or more elements or compounds, 2 or more pure substances that are mixed together physically but not chemically, as we mentioned, in a uniform matter. So every piece of the sample has identical properties throughout. So for example, if you mixed salt and water, the salt would evenly distribute throughout the water and you would have a solution or a homogeneous mixture. So if you tasted some of the salt water, it would be very salty. If you took a small bit of it from the middle and you tasted that, or you took a small sample from the edge, all of it would taste the same because the salt and water are mixed evenly, and so we have a homogeneous mixture. So we say it's has the same properties throughout. Let's contrast that with a heterogeneous mixture. Heterogeneous mixture, you have 2 or more elements or compounds mixed together physically, not chemically, but they're a non-uniform matter. So some regions of the substance contain different properties than other. If you look at this slab of marble here, you can see that some parts of the marble have a different composition than other parts of the marble. So this part right here, if we took a sample, if you can see where I'm circling here, you have a certain composition here, which is composed of minerals that are much darker. Over here, if you took a sample here, you have a different composition of minerals, more whitish or lightish minerals. So you have a mixture, but it's heterogeneous because the substances are not uniformly distributed. So be familiar with those and look around and see if you can identify and distinguish between pure substances and mixtures in your everyday life.